So we're going to continue on with our safety and health topics, this time getting a little more into the details of some of these subtopics of safety, which, you know, in looking at our flow here, you know, what we would really like is for you all to be able to look at these nodes that Russ was talking about within the treatment process and think about where you might find these particular types of hazards, whether they're health or safety. So with that, I'm going to go ahead and get Russ over here, and he's got some health stuff to start with.
Back to the commanding chair. Okay, everyone. Glad to be back. So, start out, again, kind of use the flow chart. This as a hypothetical wastewater treatment plant. And let's see, we got to get to the right place here. There we go. Let's see here. Yeah, we got to get to the right slide. There we go. Okay. So as everybody can see that now, we got some learning objectives up. That should be visible to everyone. Let's see if I can do this here. Whoops. There we go. Okay. So we talked about terminology, some safety and health ergonomic disciplines, the kind of the philosophy behind health, safety, and ergonomics. Some of the things you want to think about is thinking in a circular transitional loop instead of linear time, as we discuss, because you're going to find that we continually go into a loop of identifying hazards, looking at the standards, controlling the hazards, or thinking about the controls for the hazard, and then implementation of the controls and how that affects the worker. And understand how to use a hazard assessment table, that HAT, for the typical process of water or wastewater treatment to anticipate workplace hazards and the controls. How to use or identify types of health, safety, and ergonomic hazards for each related process or activity. So there's different ways we can look at activity. We can look at it as a trailing activity, or maybe called a lagging indicator, where the activity is in the past or inactive. So we can go back and look at perhaps like OSHA 300 injury illness logs, which tell us how many people were injured in a year and what those injuries were. That's kind of inactive at this point, but it gives us some kind of baseline, and maybe if we see a trend, where we would want to look to maybe identify as a priority the hazards and then work on the controls to prevent those hazards from reoccurring. And then there's leading, which is current and active, which actually involve more of the worker themselves actually being involved in the conversation about where you believe you identify hazards as a worker. What are the hazards, and how do those hazards affect you in your daily activity and doing your work? So those are more leading or current active indicators. We're going to also talk about how to evaluate and communicate risk using an ARM, which is an active risk management or matrix, to determine and control hazards and make recommendations and management decisions. So, because where there is unmanaged risk, there is always liability, and business really wants to limit their liability, because the more they can control the risk, the more they have control in reducing their liability. And that's always good for business. Know how hazards may change as a process or activities change, and we'll talk a little bit about that sometimes with the people that are involved in doing the work tasks, because they get involved, other hazards may come about, or it may change the perspective in which you identify hazards. And able to look up relevant hazard-related Oregon OSHA codes. You're going to find out through these slides that we have, you're going to identify that there's a code related to that. And so you could go to that code at any time and type in that code under OregonOSHA.gov, and you would be able to go to the subject index and then type in that code or look for that code. Have an understanding of the elements of proactive health, safety, and ergonomic policies. And we'll get more into that. That goes more into the third track where we talk about managing safety and health and ergonomics. When, why, and how to call on Oregon OSHA consultative services so that we basically can leverage our experience to move faster, be able to identify hazards and have a better understanding of the controls, and know of other Oregon OSHA resources and programs that are available to you through our website. So we'll get on with that now. So anticipating health, I put together a hazard summary of the types of things you're going to see in a wastewater treatment plant based on the flow chart and the different types of nodes that you have. And these are all common to wastewater treatment plants. So noise, a lot of times they come from pumps or where there's a lot of mechanical machinery. So noise is one to look at as a hazard. Bloodborne pathogens and other potentially infectious material. Of course, you're getting hazardous waste come in. We really don't know what's in that hazardous waste. So it's always potential for there to be infectious materials, other potentially infectious materials that are bloodborne related, along with the typical bloodborne pathogens. Now, viruses are probably not going to survive such an environment, but bacteria definitely does. In fact, bacteria thrives off this stuff. So also you can get things such as sharps or whatever come through the waste, the septic material. You get syringes. And so those syringes may actually contain some other typical bloodborne pathogens. It could contain a virus that may be in the just recently dropped or whatever, in the syringe was recently dropped, got into the wastewater stream. And so that's a potential exposure. Microbes, bacteria, septic conditions. So with bacteria, there's a lot of growth and death. And with that death, there's endotoxins. It's basically some of the things that we'll talk a little bit more about, but some of the myths that people can breathe that can have an adverse effect on your immune system. Biologicals, chemicals, and non-ionizing radiation. So except for the non-ionizing radiation, but the biologicals and the chemicals, it can be an airborne dry particulate. And airborne meaning it easily gets into the air and is suspended for a while. And so then you can get in your breathing zone. It could be a dry particulate, it could be a mist, it could be an airborne vapor, or it could be gases. So these are the kind of hazards in general we're looking for. You can have skin-eye mucous membrane contact or absorption. This would be especially associated with acids or bases that you may use for treatment of water. The gases from digestion would both be toxic and flammable. Hydrogen sulfide, for example, is both toxic and flammable. You have methane. Methane in a high concentration can also be toxic, but it's very flammable. And then you have your disinfectants, which could be liquids. Those disinfectants like calcium hypochlorite or something like that, or you may use UV, which again is a light, and we talked about that. So the potential damage from UV could be an issue. So those are hazards associated with that process of filtering. Laboratory chemicals basically follow along a lot with the hazard communication and GH categories and labeling, but with laboratory chemicals, it's pretty much the chemicals, it's small use. Some of them come in different kits, hot kits and things like that for some wastewater treatment plants, others that have their own lab. So we're going to talk a little bit about that, but not too much. Because it's very specific or separate category that goes under hazardous chemicals for the laboratory. And then there's confined space atmospheric hazards. In terms of an industrial hygiene point of view, we're looking at what could be associated with the atmosphere. Do we have, before we enter an identified confined space, and Randy will go into more in the definition of confined space, but before we go in there, have we even identified what the oxygen content is? So a lot of times with septic conditions, you can actually have anaerobic, so you can actually have a lot of bacteria that are using up the air or the oxygen, and so you can have an oxygen deficient atmosphere. A lot of the bacteria, like we said, hydrogen sulfide, as well as methane gases, the flammable ones. So we need to know that we're not exceeding what's called a lower flammable limit or lower explosive limit, an LEL or an LFL. Are both the same. And in the case, we want to make sure it's 10% of the LEL or the LFL, the flammable limit. And then, of course, we're going to, because hydrogen sulfide itself is highly toxic, so we're going to look for hydrogen sulfide as an individual component in a confined space where we have septic conditions. And then carbon monoxide as a possibility. So these are the kind of gases we look for using like a 4-way gas meter. So let's get to noise exposure, because I think it's one of the things that sometimes is not really looked at in terms of an immediate exposure that could cause harm. So, but anytime a loud noise can damage your hearing, it could be over your lifetime. So the louder the noise and the greater the duration, the greater the risk for hearing loss. So when you have exposure and you have a hazard to loud noise, and that duration is for a long period of time, there's a greater risk for hearing loss. And we talk about hearing loss when noise is above 90 dBA. That's decibels as an A-weighted. And A-weighted is basically saying that the equipment is tuned to human hearing. Okay, and that's a simple way to look at it. And we have that equipment that we use, and we average over 8 hours what your noise level or exposure is. And if it reaches that 90 dBA or exceeds it, actually we're more concerned when it exceeds it, we know that there's loud noise exposure that could likely result in hearing loss. And so we're required to then look at providing engineering and administrative controls and hearing protection devices to reduce noise below 90 dBA, 90 or below. And now that's a regulated code, but actually we're also concerned about noise above 85 dBA. So at noise at 85 dBA or above, that's called an action level, an AL. And again, that's averaged over 8 hours. And we're concerned with that because there are some people, like 10% of the population, that could actually develop some noise hearing loss. And so at that point, once you reach 85 dBA averaged over 8 hours, and it's an employer paid hearing conservation program that kicks in. It's an administrative control. And it requires that there be a hearing test baseline to establish what the person's hearing health is like, and then annually thereafter hearing tests to compare to that baseline to make sure that that person's hearing has not become worse or they're developing work-induced hearing loss. And then the employer is also responsible to make sure that they're trained to learn and know noise can cause how noise can cause permanent hearing loss. Mainly it's damage to brain nerve cells. If you've ever had any understanding how the ear works, there's an inner ear and it's called the cochlea. And in the cochlea, it's like a shell, that's what's called the cochlea. There are nerve fibers, which are part of your brain. And those nerve fibers move up and down. So when there's a certain frequency, they'll move down, and then that will register to your brain that that's a louder noise. But if those nerve fibers stay down because the noise is so loud for so long, they will actually disappear like grass. Like someone walks over grass a lot and that area, that grass disappears. Those nerve endings are gone. They don't grow back. So you want to know how to protect your hearing. And then where to use hearing protection devices and how to wear them. You can have hearing protection devices, but if you don't wear them before you enter a loud noise area, you really reduce the effectiveness of that hearing protection. And then, of course, required records to keep, that would be audiologist reports and OSHA 300 logs for what we call standard threshold shifts, which is an STS, which means that there is a potential for loss of hearing due to worker exposure. So that has to be logged on the OSHA 300 log. Okay. So when we talk about sound, we're talking about sound that is necessary for us to function. But when that sound becomes noise and harmful, we've already said that that intensity is 90 dBA or greater. And at or above 85 dBA, we have to document that the employee needs to pay, or the employer needs to pay employees for annual hearing testing, training, and hearing protection. Now, NIOSH says, NIOSH is National Institute for Occupational Safety and Health. And they say anything greater than 85 dBA is considered noise harmful. So there's kind of two schools of thought. Well, what's important here is to realize that 85 dBA, once that kicks in, the employer has a lot of responsibilities to ensure that the noise does not try to exceed above 90. So you're going to try to keep it between 85 and 90 if you can. And ideally, if you can engineer the noise out so it's less than 85 dBA, then the employer doesn't even really have to consider that, be concerned with the noise exposure program. Also, recent studies show use of earbuds can actually cause unsuspected hearing damage. So when you see employees wearing earbuds, there are some out there, of course, they do seal a little bit around the ear, but typically they have to turn those earbuds up higher than the ambient noise. And if the ambient noise is above 90 dBA, then they're turning those earbuds up, or the volume up through their earbuds. And you can see, this is what I'm talking about, those normal hair cells that are on the bottom right. It's healthy. You can see that they're all in line for the frequencies that's necessary for us to pick up the different frequencies of like, was it like 16,000 or 20,000 hertz. So there's a big frequency band, but if you see damaged hair cells, you lose a lot of those frequencies. And when you start losing those frequencies, you can't hear vowels properly. You can't hear constants, the constants properly in our language. And you actually lose the ability to talk. I mean, every day we're reinforced of how we're to pronounce words. And when we start losing our ability to hear, we lose that ability, that reinforcement, and our words start sounding funny because we don't get that feedback.
So another way to look at these are called stereocilia.
Oh my goodness, this guy is just a technical genius. Go ahead, Randy.
So if you guys have ever been to like a rock concert, anyone here? I only see one person on video, but I'm sure we've all been somewhere loud, right? So you probably noticed that after it, you either have ringing in the ears or you're not hearing as well. And then maybe you turn your radio on. The next morning you get in the car and it seems very loud. What that is actually the pressure waves and the fluid that go through your ear and the cochlea actually impact those cilia and knock them down. And most of it will recover, which is why the next morning the radio seems louder than it did the day before. So, but some of them do not recover, and over chronic exposures, you see where we become into that damaged territory, and that's not coming back. So, just another way to think about it.
No, that's a good way to think. That's why my analogy was like walking over grass a lot of times. You know, the noise is too loud. You're constantly getting bombarded with that, and then all of a sudden you lose the ability to hear those frequencies simply because those hair cells have actually been damaged and they won't come back. So they're not replaceable. So we want to assess the noise exposure, and that's done in a workplace. And we measure the risk using a sound level meter. Now, sound level meters are typically used just for screening. There's actually a NIOSH phone app that you can use to do screening. That would measure for basically anywhere from 90 dBA or 80 dBA up to, ridiculous, like 120 dBA, which is highly hazardous. But anyway, it measures dBA. You have to have it for a specific activity and a task at a specific location for a given period of time. Typically, when I do screening, it's for like maybe a minute or 2 minutes, just to get an average of that time. It's less accurate than if we use a noise dosimeter, but the readings that you get are more conservative, because a noise dosimeter will take into consideration the whole 8 hours. And so there's break times when you might not be exposed to that at that specific location. You may go off somewhere else. But it estimates noise at the action level, or the PEL, or I forgot to say the PEL is 90 dBA or above. And then handheld. Typically these, the sound level meter is a handheld, so you have to hold it close to the person's ear in the work activity that they're doing to get a relatively good reading. Now, a noise dosimeter, this is different. It measures the dBA like it does with a sound level meter, but as the employee works through an 8-hour shift at different locations on different tasks, it integrates the time along with the noise exposure over the 8 hours. It's more accurate, and it's actually used for in not just consultation, but in enforcement activity. And it can measure the noise action level, PEL, and that NIOSH I talked about, the National Institute for Occupational Safety and Health. They have what's called a REL, a recommended exposure limit. So we actually, under this noise dosimeter that Oregon OSHA consultation has, we can come out and do noise exposure monitoring for you. It doesn't cost anything. It actually has three meters in one, but it averages everything over the same 8 hours. And the nice thing about this is placed on the employee to wear. So wherever they go throughout their work area, you've actually got a really good, accurate data field in terms of knowing what their exposure is for what they do over an 8-hour period. So bloodborne pathogens and other potentially infectious material, you can see that the code up there, Division 2Z 1910.1030. So anyone that is alive today is considered to carry a bloodborne pathogen and other potentially infectious material in human blood. And that term is considered a universal precaution if you're in the health industry. So bloodborne pathogen and OPIM have an exposure potential, especially for skin abrasions, an opening or a puncture from, like we talked about earlier, like a syringe, especially used syringes. There may be other sharps that's considered that would cut or cause an opening, and it may have small amounts of blood on it, or other potentially infectious material, bacteria, especially in septic conditions. Yeah, very much so. And then splash to the face and eyes with any human blood. Although anything that's septic, I would not want to have splashed to my face and eyes, honestly, because of the bacterial load. It's very hazardous. And then employees potentially exposed to bloodborne are risk of HIV, human immune deficiency virus that can lead, or a human immune virus that can lead to AIDS, which is autoimmune deficiency syndrome. But there's also other things like hepatitis B and C virus. And I guess there's A, D's, and E's now, and some of these are not even treatable. I think hepatitis B and C are. And then there's other bloodborne pathogen like parasites that would be considered to be possibly carried through septic conditions. And potentially exposed employees required controls. So you want to have a limited amount. We can come out and help you with that, a limited amount of annual training so employees understand what those exposures where they might come from. And the use of sharp containers first of all, don't pick up any sharp directly if you can help it by hands. You want to use something like pliers or I don't know, forceps or something like that to pick it up, and then put it in the sharp container, specifically to find sharp containers. They're usually plastic and they're rugged, and they actually are designed to hold the sharp so nobody gets poked. The use of PPE is limited, but it would be great for like face protection. So you have a face shield, you have gloves, you have an apron, those kind of things prevent splash, because splash is a big issue. Now, if there's a mist, it may even require that you wear a respirator. We'll get into that a little bit later. And then follow employer's written bloodborne exposure control plan, again, another administrative control, and offer employer paid hepatitis B vaccines at time of employment or time of exposure. Now, we have a thing, Ergonomics has a thing called bloodborne pathogens collateral duty clause. Yeah, thank you, Brandon. Collateral duty clause. And in that collateral duty clause, it allows for the employer to bypass a lot of the bloodborne pathogens requirements, except that you have to provide employee training, and you have to make sure that you can get to an occupational health clinic within 24 hours that actually has the hepatitis B vaccine, because it's important for them to get it within 24 hours in order to be that vaccine to be effective. Otherwise it loses its effectiveness after 24 hours. So that window is very important. And so already have that lined up. That would be part of the employer's written bloodborne pathogen exposure control plan.
Definitely recommend getting it ahead of time.
Yeah, ahead before it's needed. Then microbes, bacterial endotoxin hazards. This actually has to do with the more of the PPE. So we're looking at Division 2 and then 437, 02, 134, and 1910.134. 1910.134 actually deals with the respirator, which we'll get into here a little bit. But microbes can present, especially in septic conditions we've been talking about, spread disease. The greater the exposure, the greater the risk. Associated with airborne exposure when there is a mist, and this could be from the sludge or accidental ingestion, meaning that you breathe in the mist, it can also breathe into your mouth. So basically you're ingesting as well as breathing it in. Endotoxin exposure can result in flu or cold-like symptoms, respiratory symptoms, fevers, chills, eye irritation, high white blood cell counts. There is a school of thought about acclimation. So a small amount of exposure to these endotoxins where there's a lot of potential bacterial load from mist, this can allow slow exposure and reduce the time out ill, because your white blood cells do build up, and your immunity, it has time for your immune system to properly react. Typically what happens is that you get such a huge load that your immune system kind of goes haywire and really has a hard time. So it feels more like fevers and chills instead of acclimating, and where your immune system is there's less of a load on it. And so it can actually properly react without overreacting, preventing the fever and chills. The control of the mist. Okay, the control of the mist can reduce risk of exposure, as proper use of PPE can reduce exposure. And then, of course, the hazard assessment. And we'll get into that a little bit more, but employees want to know when to use, how to use it, limitations, maintenance, and life expectancy. And here's some endotoxin risk exposures. So this is the suggested occupational exposure limit, OEL. 0.03 micrograms per cubic meter to 0.1 micrograms per cubic meter. So there's really nothing in OSHA standard that says that this is the requirement. So this is suggested, and it's found in incoming water and trained with basins and sludge treatment inside biofilter towers. It's necessary to control and reduce exposure to airborne bacteria and endotoxins at wastewater plants. And the types of bacteria are listed here. I'm not really good at mentioning all of them. Chemical use and hazard communication. So you can get into several different types of chemicals. I've just listed some here, and you can see. So the ones that say solid a lot of times those exposures, if they're airborne, they're like a powder, but typically it's going to be particles not otherwise recognized, or PNORs, and they're going to be about 10 milligrams per cubic meter. However, you get into your corrosives and you're going to have other kinds of exposure limits. You also want to check your hazard communicate or your safety data sheets for other occupational exposure limits. So measuring chemical and biological exposure, we use inhalation. It's a respiratory system you want to protect. You want to see the safety data sheet for any specific chemical exposure levels. Oregon OSHA has several different exposure levels. Solid particulates, it's always measured in dry particulate per cubic meter of air, and can be total or respirable size, meaning respirable size, it gets down deep into the lungs, where total, it's both, it'd be like starting from the nose down to deep to the lungs. Liquid aerosols, mist can be measured as milligrams of aerosol per cubic meter of air and can be total or respirable size. And then gas vapors are measured in parts per million, part of toxin, a million parts of air. And the skin, hand contact to mouth, accidental ingestion. Usually use wipes for skin and surfaces, but it's a screening tool just to give us an idea. There's really no quantifiable amount. We have some idea, but it's not, it's kind of semi-quantifiable. And then eye mucous membrane exposure, it's really not quantifiable. It's just, were you exposed or not exposed? And here's the code for chemical exposures up there. Kind of see one of our tables, E1, as an example. You can see parts per million or milligrams per cubic meter. We list it in both, and whether there's a skin indication to it as well, meaning it potentially can be absorbed through the skin, so that would add to the dose. Exposure risks, many chemicals require clearance time. So for an 8 to 10 hour per day, the clearance time is 14 to 16 hours to be removed from the body through cellular metabolism, excretion, prevent a buildup and body burden to prevent illness. So the 14 to 16 hours is usually when you're away from work. Occupational exposure is designed to allow levels up to a certain dose per day in the body that can be safely excreted over time for a healthy individual. So there's different OELs. There's the Oregon OSHA PALs, which are rule requirements. Then there's the NIOSH recommended exposure limits, ACGI threshold limit values, and AIHA, American Industrial Hygiene Association wheels, which we don't use very much. It's one we can use, but we don't use it very much. And chemical biological exposure hazards, exposure routes, again, skin contact, you may develop sensitivity, irritation, tissue damage. Adsorption means it gets absorbed on the top of the skin. Absorption means it goes carried through the bloodstream and goes into tissue and the circulatory, through the tissue into the circulatory system, and can become systemic throughout the body. Eye mucous membrane contact, again, tissue irritation, damage, absorption, adsorption, absorption. Respiratory systems through inhalation that can cause irritation, inflammation, sensitivity, tissue damage. It can anywhere from the upper to the lower parts of the respiratory system, which would be the lungs, and then systemic throughout the body. And the digestive system, that would mostly be through accidental ingestion, but that'd be through contamination of food and drink. This could cause irritation, tissue damage, or systemic damage. Surface to hand to mouth would be poor personal hygiene, which is another way to get a good bacterial load or something of a hazardous chemical into your body. And laboratory chemicals, just want to say it's an application for small scale use or hazard communication program, but you have to have a chemical hygiene officer if you're going to go as laboratory chemicals through the code. And it has a written safety work practices, use of fume hoods, other controls, review of chemical reactions and safety data sheets, and identify hazardous chemicals such as carcinogens, reproductive, mutagens, teratogens, highly toxic chemicals, and restrictive use practices and security. So we've gone through chemical, bio, and noise. Engineering controls, we kind of talked about that, how they're isolated or capture or collect local exhaust that can be used. Administrative, we talked about. PPE, we talked about. PPE always requires a hazard assessment, training, and respiratory protection. And then noise, again, you can have isolation, shielding, distancing, monitoring for the hearing conservation program, scheduling and training, and then PPE use. The NRR is a noise reduction rating, and it's given to every kind of hearing protection device there is, and you use that in a certain way to determine the attenuation that you're able to obtain. And then through UV, you'd have engineering, administrative, PPE, ANSI grade, probably. And then these are some of the applicable Ergonomics standards for the health-related codes. And now Randy's going to start talking about the health and safety-related codes. Okay, Randy, you're on.
All right. Try to make sure we have enough time for some questions. So when we get into the safety side of things, this is going to be a really, I think, basic level. But certainly, when we think of where injuries occur, they're really in common sort of places. And the picture right here is a good example of that. Clean shop is a safe shop. We've probably all heard that. And it's just something that, you know, anecdotally, I can tell you that whenever I go into a workplace that has a cluttered situation like this, you know, you can find, you know, 20 serious OSHA related findings on average, given that scenario, ranging in topic. So yes, there is something to be said for that. Now, under the working surface standard, we do have to make sure that our walkways are clear, aisles are clear, and especially our egress routes are clear. So, and that's, I've put some standards at the bottom of the slide so you can sort of see where we are with that. But fall protection, going to be another big one. What is fall protection? Well, anything that prevents a fall. So that guardrail is fall protection. At the same point, this harness is fall protection. So the idea of fall protection is it's a system. So it's either one control or it's multiple controls. But in this case, the system that this particular person is wearing is a harness. I would say that the ring there is a little bit low on his back, potentially. But so maybe there's a fitment issue there. But we have a harness. We have a lanyard, some type of deceleration device, potentially, depending on the type of fall protection. We have a snap hook at the end, and you know, a snap hook that goes to the D-ring on his vest, and we have the attachment point for the anchor. The anchor is the lifeline, the horizontal lifeline. Sorry, my dog's going nuts. So anyways, the idea here is that when you choose fall protection, you have to think about it, the whole picture. And oftentimes the thing that gets forgotten is the anchor, which is basic rule, 5,000 pounds per person. If you're going to have multiple people on a horizontal, let's say 3 people on a horizontal, that's 15,000 pounds minimum, right? Now, usually you would see more like 17,000 if that was the case. You would have even a little more than. So these are just examples of that. If you're working on a roof, when do you need fall protection? When it's above 4 feet. That is when fall protection kicks in. And usually at 4 feet, that's where we have our guardrail. That's just, no one wants to wear a vest unless you have to. They're not, the harnesses, they're not very comfortable. And if you've ever been suspended in one of these, I'm not sure if anyone here has ever experienced that, it's quite painful. That's a really nice harness there. It's all padded. They make attachments which send out these little straps, and you kick them under your feet so that if you're suspended waiting for rescue, you can put your weight on your feet. The problem with these is that if you're suspended, you can actually have what's called suspension trauma, where the blood flow is restricted in your legs specifically. And if you're left long enough, it can become toxic essentially and become really difficult for first aid. So the rule is we got to be able to rescue someone within 15 minutes, but I would actually say it's better to shoot for like 5, because trust me, when the blood flow is cut off, it doesn't take long for some problems to potentially happen. And if you're going to rely on a fire service to come rescue you, be very careful about estimating that time for their arrival. So, and for their setup to go and rescue the person on top of that. Their arrival may be quick, but to actually get set up to do the rescue might take longer than you want. So here's some netting. You know, if this is becoming more prevalent in construction, it's nice because you don't have to wear a harness. There's some folly with it, but it is an option. And it also acts as falling object protection as well. Again, anchors, there's various kinds here. So these, I thought these were kind of neat. These go on like rooftops that you don't want to penetrate, say for weather sealing or something like that. But they're mobile and they'll hold, 5,000 pounds. There's a water bag set up, and then there's like a steel plate set up. So those are some examples. There's all kinds of anchors. And what I would recommend is looking at like DBI Sala or 3M if you have needs for this. Their vendors and reps will be able to find a product that fits your need. And I recommend investing if you need fall protection, invest in it, because they sell cheap harnesses and they sell expensive harnesses. I would recommend the expensive harnesses because these harnesses, again, can lead to injury. So from a best practice example of the fall protection in place at a place where there is trucking. So they have implemented a overhead system to do a retractable yo-yo type lanyard system. These were really hard to guard back in the day, and they used to actually have even letters of interpretation that you didn't have to tie off. But think about it, a truck that tall is well over 4 feet, and we see fatalities at 4 feet or less than 4 feet sometimes. So, if we can prevent that fall or at any cost, it's worth it. Next up, ladders. Ladders, the hazard is fall, just like fall protection. Only difference is you don't have to wear fall protection on a ladder, but you have to use the ladder correctly. This is an example of not how to do that. So get the right ladder for the job. Make sure that employees are trained on ladders. Ladders scare me more than things that cut. Like, for example, when I go into a woodworking shop, table saws, yeah, they're scary. It's the consequence of an incident is it's gross and high risk potentially. But the ladder is where we see so many falls, sprains, strains, contusions, broken bones, fatality. That these are really a nightmare. And if you can eliminate these kinds of ladders at your job site, it's going to be better. Using a scissors lift is way safer. Using a boom lift, an aerial lift is going to be much safer if you can logistically make that happen. Now, there is requirements for these too. Got to be trained and certified on operation, but these give you a better work surface and more stability to do the task. Typically, if you're working on a ladder, you're using your hands, right? So what are you holding on to the ladder with? It's just kind of leaning on it. And depending how high up the ladder you have to be, maybe not that much stability. Here's another example of a ladder that's got a built-in protective device. I'm seeing these more in construction now. They're trying to get away from A-frames. Some of them have guardrails, some don't, but the point is that he's standing on a big platform there. And so because of that, there's more stability to do the task with the hands. So I've been recommending my clients consider switching to these. Make sure you have the proper height that you need. That's the drawback to these, but these are also wider. They have a bigger footprint, so they should be more stable. Given you have a flat surface, that's always the challenge with an A-frame ladder. How many of us have tried to use an A-frame like in the grass? It's really like trying to get on the roof or something and things wobbling around on you. So, materials handling. Okay. We're going to get into forklifts, back to ergonomics, some crane talk, and you know, really materials handling is pretty broad, but sometimes it all gets summed up as that picture in the top left, forklifts. Forklifts are, you know, that like you see in that bottom picture. They can result in a lot of lost time. They can result in horrific injury and fatality, and as well as property damage. So it's really important that our employees are trained and certified. They have to be certified by the employer at least once every 3 years. I teach a 4-hour class on that through our public ed. If you guys, if anyone needs to come to that, we teach that one regularly. So cranes got to be inspected, have to make sure that all the components are rated properly, meaning that everything is rated for the proper weight that's going to be on it, from the hook to the cable or chain or rope or whatever the hoist line is, to the actual crank unit itself. Everything's got to be rated correctly. Some cranes have to be inspected annually by certification. It just depends on the manufacturer and the capacity at that point. Storage racks. Storage racks can lend itself to a lot of hazards. Weight, knowing the load limit is really important. For example, stable loading, putting heavier things down low is a good practice. If you're going to be hand pulling from a storage rack, it's good for that to be at the optimal height from an ergonomic perspective. Do we get a question? Let's see. How often are we supposed to be trained and certified to use man lifts and scissors lifts? I believe that man lifts and scissor lifts, I may want to look that up. I think it's the same. I think they're considered a powered industrial truck. So, I mean, the standard says powered industrial trucks, not just forklifts. But I will just see if I can find the answer to that at the next segment. Good question. I recommend doing it the same. You know, you can't go wrong. And I would even say annually instead of every 3 years, because it's easy to forget. Okay. Now, electrical hazards. So, you know, I just have some examples of electrical hazards here, but, you know, in one of these are electrical panels. One of these has, on the left, we can see that the one on the left has no dead front, right? So all of the protective devices that are designed to be on a panel need to be in place. That includes blanks. So if you have switches that aren't being used, you got to have a blank in there. No openings that lead to that bus exposure behind the scene there. This is where high severity risk is within these panels, because you're talking like this right here is probably minimum of 200 amp service, something like that. So if those bus bars have an arc, you're talking arc flash, absolutely. So the easy thing with the easy rule of thumb with electrical is needs to be designed in accordance with manufacturer's specs and recommended usage, as the UL White Book would spell out. Damaged electrical cords like this, if you see that, here's an example of a failed strain relief. This is really common to see. On the other end of this plug, you might see a missing ground pin. I mean, these are really kind of easy to spot, but you know, it kind of begs the question: is there an inspection program for the equipment? When I go and we do a consult at a facility, I'll kind of look behind things and look for these cords and look for drills and look for things that might have been modified. Here's an example of modification of electrical equipment. And this is where YouTube will fail you. I love YouTube, but how to build a totally guaranteed to get an OSHA citation extension cord, that's the bottom left. that box is not designed for temporary usage as a permanent installation. So it has to be used in accordance with the design specification of the manufacturer. And on the other end of that plug, we see that they also added a new plug-in to it. So my question to that is, did a certified electrician do this work? We have standards for actually working, like doing the actual work on electrical. So there's a standard for the electrical item itself, or the once an installed product, and then we have a standard for the work practices. So those are some questions I would ask. I would probably not recommend having anything like that on the job site. And then like there, how to add a cord to a cordless drill. Again, how to get a really low hanging fruit OSHA citation. It's inventive, but it's it effectively can compromise the safety of the device. If it's installed improperly, you can have a case where you have an energized case of a tool. So if you step on the right ground surface, you could become part of the circuit essentially. And we have fatality cases that involve that. Confined spaces. We were just in a breakout, and then we see that you guys or some workers may be going into manholes, and we have a whole rule on this. Russ talked about atmospheric hazards. We want to assess the atmospheric hazards. We want to use our multi-gas meters before we enter there. Make sure it's in the happy range of breathable air, grade D at least. And we also want to make sure that there's no physical hazards. Is there moving parts? Is there electrical hazards? Is there engulfment hazards? Is there could there be a pipe burst and flood and be a drowning hazard or something like that? Asphyxiation hazards, hydrogen sulfide, those are atmospheric. But now we look at the spaces here, permit and non-permit confined spaces. They're both confined spaces, but one is permit and one maybe not. It depends on if there are hazards. If it's just a confined space and there's no hazard, it's just a concrete vault, and that's it, there may not be a hazard. So you may just have a confined space. Doesn't mean we want people going in there, but that's something that the employer has to classify. In the case of that tank, they have classified it. I don't know what's in that tank, but they have classified it a permit entry. Therefore, they have to go through the permit process. And here are some definitions of that. I don't think I'm going to read it all, but basically, here's the major caveat between these two. The first one, you need to go through, is it a confined space? And if it meets, it must meet all three of these conditions, if that makes sense. It must be large enough to enter, limited or restricted entry or exit, and not designed for continuous employee occupancy. So probably not going to put a desk in that picture on the left or the right. I would say those are confined spaces. Next, is it a permit space? If it meets any one of those conditions individually, then it is a permit space. That's the difference between those two as far as differentiating. So basically, if there's a hazard, permit space. There are some other caveats with that, but we probably don't have time. Okay, 5 minutes left. I'll go really quick, and then if anyone has any questions, go ahead and post them up. There's a permit right there, so you can see, but you can Google confined space entry permit. I don't have really enough time to get into alternate entry, but that's another form of permit entry. It can save you some time in certain instances. Machine guarding, whatever the hazard is, at the point of operation, moving parts, being pulled in by a belt, chain drives, things like that, we have to guard those. So we have specific standards on all of these different pictures that I have here, But a good rule is if there's a moving part, if you could be hurt by contact with something on a machine, it needs to be guarded. So I think enough said about that. Oopsie, what's happening? There we go. Got to keep bathrooms clean and supplied. Got to have tepid at least water, and we even have requirements for how many facilities have to be in place. So not going to go fully into that. I think I'll probably have to cover ergo in the next. Well, ergo is a huge amount of workplace injuries, and you know, the better you can prepare yourself for a job, it will be preventative. So I recommend doing things like stretch and flex. This is getting really big in construction right now, and it is reducing incidents. So they use this as a group activity to start the day.
I think it's someone that knows what you're doing to do the stretch and flex.
Yeah, and so there's a couple of benefits other than just getting your body warmed up with doing this, and maybe in the next section I'll cover that. But and total worker health is there as a service, which when we get into ergonomics, we look at basically we would like to have a happy, healthy workforce, and we want people to want to work for us and not have a constant turnover, and we don't want anyone sick and dying, especially from work. But we also want to provide resources that help employees outside of work if there are stresses that are affecting them as a whole, because again, when we see stressors outside of work, they absolutely do affect work performance. So but ideally we want everyone happy and staying with us, right? So this is a good resource for that. Talks about some different factors to consider and ideas. So it's kind of leading edge stuff. I don't see any other questions. So what I will do is I'm going to look at that. Who asked the question there? William Tucker. Okay, William, I'm going to look into that while we take a break, I think. And then hopefully you'll be in the next segment, or I'll just try to send it back to you. So thank you.